Okay, so welcome back students. So today we are going to understand the queue. What queue exactly is. It is also a data structure. In my previous class we have learned about the stack and we also implemented stack. Okay, so in this particular class we are going to understand what exactly a queue is. So what is a queue? Normally when we say okay please stand in a queue, when we say to our students that please stand in a queue, so what does that mean? That means that the students are supposed to stand in a queue. Or suppose you are actually standing in a queue in a shopping mall. So if you are standing in a queue in a shopping mall, what does that mean? That means that the person who is at the first in the queue, okay, will be the person who will be served first, isn't it? Means he will be given the opportunity. Or example, like you're standing in a queue for a movie ticket. So the person who is first in the queue will be the person who will be getting the movie ticket first, right? Or will have the opportunity to buy the movie ticket, isn't it? And then the second person will get the opportunity, then the third, then the fourth, and the person who is at the last end of the queue will be getting the last opportunity. So first, the first person like who comes in the queue will be the person who will be getting the services first. So the order is first in, first out, and as what you can see over here, that is first in, first out. That's the order of a queue. So that's a FIFO, and for the stack we have LIFO, that is last in, first out. So a stack works in LIFO order, so last in, first out, and a queue works in a FIFO order, that is first in, first out. So if we have a list and there are numbers in the list, and we keep on putting numbers into the list, so the number which we had added to the list, that was the first number. And if we really want to perform the operation, that we want to take a number out of it, so the number that was the first in the list will be taken out. Okay, so stack has two operations, that is push and pop operations. Okay, so these are the two operations that we perform on a stack, that is push and a pop operation. But for queue, we will not call them as push and pop. There are two words, that is called as Enqueue and Dequeue. Enqueue and Dequeue. Okay, so these are the two operations that we perform with a queue. So let us understand the operations of Enqueue and Dequeue with an example. So this is an example, and now you can say that this is a empty queue. Okay, so when we are going to implement this in Python, this is going to be a list actually. As I said, children, that stack and queues are the data structures which are used by the OS. So this has a lot of meaning. What we are doing out here is we are just trying to understand what a queue is and how a queue works. And we are going to demonstrate, we are going to implement that using the Python code. But in reality, okay, we are just going to demonstrate how a queue and a stack work, just what we did in the previous class. But in reality, stack and queue has a lot of other works that they do, okay, for a system software and for the memory management as well. Okay, so this is just we are trying to understand. So what is happening over here is we are demonstrating this with the help of a list, which is a data type of Python, isn't it? So if this is a list and these are the blocks, and we are going to take two pointers. Okay, the two pointers, and the pointers will be like this is front and end. Okay, let us have two pointers. You can name them anything. I have named them as front, and I should have this as last, but that's end. Okay, no problem. So front and last, or front or end, it does not matter. So these are the two pointers, and since this particular queue at the moment is completely empty. So front and the end pointers will be pointing to what? Will be pointing to nothing. So that is none. In my previous class, we had given -1. So -1 means like pointing to nothing, but we can use the none also, right? The none data type. So front and end, they are pointing to none, and right now the queue is absolutely empty. And then we are going to perform the enqueue operation. This is enqueue operation. Okay, so let us perform an enqueue operation at the currently the pointer that was pointing to none. Okay, so what I have done over here, I have performed a enqueue operation, and once I perform the enqueue operation, I'm going to insert a element into the queue. Okay, that's the first thing. And where does it will go? Practically it is going to go in a list, and that will be the first item in the list. So the index value of that particular list is going to be 0. So I'm going to increment my pointers, that front and end, both these pointers are going to point to this particular index value, since there is one element in the list. And as we are talking about queues, so we are going to say the word queue. So the one element that we have in the queue is 25, and front and end both will be pointing to the same number. Okay, now let's go ahead and put one more number into the queue. That is, let us perform one more enqueue operation. So once I perform enqueue operation, there will be one more number, and currently the number is 50. And now what is going to happen is, front is always going to point to the first element of the list of the queue, and the end is going to get incremented every time, and so it is always going to point to the end. Okay, so I have incremented end, and front is always going to point to the first item in the queue, to the first item in the queue. Okay, end is going to point to the last item of the queue. So if I perform one more enqueue operation and I put one more number, that is 70, so you can see that the end is always pointing to the last element, to the last item in the queue, and the front will always point to the first item of the queue. Then what is happening now? Let us perform a dequeue operation. Okay, so I performed 3 enqueue operations, and now I have performed one dequeue operation. As you can see over here, this is a dequeue operation. Okay, that's a dequeue operation. Okay, so you can see this is a dequeue operation. So what is happening? Once I perform the dequeue operation, so the element that was that was first in the queue will be the element that will come out of the queue. So what was the element that was first in the queue? The number was 25, right? Since I performed the dequeue operation, so that particular number is going to be out first. Why? Because that's the order, that's the FIFO order, first in, first out. Okay, and then what I need to do, once I just you know perform the dequeue operation, I need to adjust my pointer, and now you can see that the front is pointing to the index value, that is 1 and not 0. Why? As I said earlier, that front is always going to point to the element that is first in the queue. So now that 25 is out of the queue, so 50 becomes my first element of the queue, isn't it? And so the front is going to point to the index value, that is 1. Okay, so we need to increment that pointer. Please understand this. So that was the dequeue operation, and now suppose if I perform again an enqueue operation. So if I perform an enqueue operation, end is going to point to the index value, that is 3. So now it is pointing to 45. And again, if I perform an enqueue operation, so obviously it is going to point to the index value 4, and the item that I have just put into the queue was 10. So these are the items, right? And these are the index values, and front is pointing to 1 because that's the first element of the list, because that previous number was out of the list. So this is now the first item in the list or in the queue. and end is pointing to the last item. Now children, please understand, since we are working with Python and we are going to make use of a list out here. So list, it grows, right? Dynamically it grows. We keep on putting elements into the list, items into the list, and it can grow to an extent or to a point where the memory is filled up, or the memory is full. So so the list can grow, but the languages like we have C or C++. Okay, these languages are static languages. So when they are static languages, they don't have a dynamic approach. So I can declare an array of fixed size. So if I declare an array in C or C++, so it will be of a fixed size. Suppose it's the size of 10. So I can only go till 10. So I can only add 10 items in the array. Okay, that is what it means. So right now, if you really say that this is the fourth, these are the 5 items in this particular list, and if we assume that there will be only 5 items, that's the capacity of the list. So this will be the last item, and then after this we cannot do any enqueue operation, and it will say message like overflow. But since in Python we are making use of list, and list grows, isn't it? We do not declare any size of a list. We straight away keep on putting items into the list. So it makes no sense out here. But if you really want to implement this in C and C++, then there is a lot of coding that you need to do, and a lot of pointer manipulations also you need to take care of. But all this makes things very simple as far as Python is concerned. So when we are working on Python, this becomes pretty easy, and that is what the motive of Python was always. That is why Python was born, to make things pretty easy. In a few lines of code, you can achieve a lot of things, and that is why we have Python. But yes, C and C++ are the programming languages which actually give you uh, a lot of logical tasks. They will give you a lot of logical tasks, and if you overcome them, then your logical thinking also improves a lot. Okay, it depends, children. So if you really want to work with these languages, you can go ahead, you can start working with these languages as well. So, but that does not mean that if you become a Python programmer and you won't be a good programmer. It does not mean. It depends on how many projects you work with. Okay, so it's your choice, absolutely. So right now it will not make any difference. If I really want to do some more enqueue operation, I can go ahead and perform the enqueue operations. Okay. So that is the one thing I wanted to make it clear to you. So right now this is the situation. Front is pointing to 1, that is the first item in the list and or in the queue, and the end is pointing to index value 4, and that's the last item. So we are going to, as far as this example is concerned, we are taking the capacity as 5 items. So we can feed 5 items in the list. Okay. After this, let us just perform all the dequeue operations. So if I perform the dequeue operation, what is going to happen? The first item that was there, 50, it is going to be out of the queue, and then I need to adjust the front pointer, and now you can see the front pointer is pointing to the index value 2. Then if I go ahead again, if I perform the dequeue operation, so what is going to happen is what is going to happen is uh, that the pointer is going to get adjusted. So you can see 70 is out, then the front pointer is pointing to 3, because now the item that is 45 is the first item in the list. And if I again perform the dequeue operation, 45 is going to be out, and the pointer, you can see the front pointer over here is again incremented. And again, if I perform the dequeue operation, so what is going to happen? There is no items in the list. So again, the front and the end both are going to point to none, and these are the numbers that are out of the queue by performing the dequeue operations. Okay, out of the two data structures that we have understood, that is stack and queue. Stack is something that we are going to work with more. Okay, so these are uh, the two data structures, that is stack and queue. So for stack we perform two operations, that is push and pop, and for a queue we perform two operations, that is enqueue and dequeue. Fine. So this is how a queue works, children. And then there is something called as a circular queue. Now circular queue also makes no sense in Python, but it makes a lot of sense in other languages like C++ or even Java. Okay, what exactly is a circular queue? Circular queue is, suppose we take the same scenario out here. So this is the same scenario where we have 25, 50 and 70. So these were the numbers that were present in the queue, and these were out of the queue performing the dequeue operations. After performing the dequeue operations, these are the numbers that is out of the queue, and then these are the numbers that are left in the queue. Okay, now what happens in a queue is, as compared to a stack, so in stack, like the last item that is inside the stack will be out, and so again you can push some items into the stack, right? If there are 10 items in a stack and you pop 9 items, and then if, assuming that the capacity of the stack is 10, so if you pop out 9 items, and then again you can push 9 items, right? Because the 9 items are empty, the 9 blocks will be empty for you. But if you talk about a queue, what is happening over here is the front is always incrementing. Over here, if you talk about this particular example, so 3 items are outside the queue, performing the after performing the dequeue operation, and now the front is pointing to the index value 3, and end is pointing to the index value 4. Assuming that we have more items, maybe the capacity is 10, so I can keep on you know putting some numbers into the queue, performing the enqueue operation. And if I really perform the dequeue operations, then the front is always going to increment, so it will go till end, right? So the front keeps on incrementing. Now if I really want to put some items in the list, still I cannot do it, because the front and end, they both are like, end is pointing to the end always, right? So I cannot put any items in the queue, though there are some blocks, these are empty blocks, isn't it? I cannot put numbers in this block, though these blocks are available for me, they are empty. I still cannot put numbers in this block, because the front keeps on incrementing, the end also keeps on incrementing. That's the problem. So what's the solution for this is, we have a circular queue. And in circular queue, what happens is, suppose we have these numbers like 45 and 10. Okay, 45 and 10. And then if there are some empty blocks that are available, so what we are going to do is, we are going to make this a circular list or a circular queue. So what is going to happen over here, the front is going to point to 3, that is the last, or that is the first item in the queue. And if I really want to perform a enqueue operation by which I can put a number into the queue, now there are 3 blocks that were empty. Okay, so I'm going to make use of that 3 blocks. I'm going to put that number into that first position, and now you can see that my end is actually pointing to the index value that is 0, and this actually makes this entire queue a circular queue. Please understand this. So if I have some more number, so that number will go over here, maybe I have 20, and now my pointer will be pointing, that is which pointer, that is the end pointer will be pointing, so I'll write here end. Okay, so end pointer is going to point to 1. Okay, I can again I can feed one more number, I can give 50 out here, and now my end pointer is pointing to what, is pointing to the index value, that is 2, and that's it. After this I cannot put any numbers because the blocks are not empty. So this goes in a circular fashion. Even this, children, you can implement this using C and C++, but as I said, we are using Python, and we will not have any issues with the size of the list, because the list can grow dynamically. Okay, but this is something that you should know, and this is how a circular queue works. So I hope this is very much clear to you. So let me just discard this and come back to Python. that is the spider. And let us implement this particular code. Let me just see. Okay, we have some time. Okay, let us just very quickly, I will just implement the enqueue and the dequeue methods, and then rest of the things, children, I will leave it to you. Please complete this entire program. So we have the enqueue, and we are going to have uh, a queue which is going to be a list. Name of that list is queue. So I'm going to pass that queue and the item that we need to put inside the queue. And the same things we are going to do over here. We are going to check whether, first thing is whether the queue is empty or not. Okay, that's the first thing that I'm going to check. Or uh, okay, if it is, then I'm going to, you can declare this as a global variables, front and end. That was the name that I had given. You can give any name, children. Front and last, or you know, front and rear, even these are the names you can give. So if it is empty, front is going to be none, end is going to be none, and else what you can do is straight away we can put the item into the list dot, something really went wrong, invalid syntax. Acha, this is going to be double equal to sign. Okay, and now I can go ahead and just perform some operations. And then the item goes inside the queue. Okay, and once that happens, then I need to, end is always going to point to the end of the list. So what I'm going to do is calculate the length and give that -1, and front is always going to point to 0, but this okay, I'm just going to keep front, uh, depends on the dequeue operation. So let us just assume front, if this is the first item. So what I can do is over here, okay, what I can do over here is how we are going to see that what exactly is the, because once we remove, okay, okay, this is, front is always going to point over here to 0. Now please understand, children, if you really implement this using a list, what is going to happen, I'm going to tell you is, okay, after removing, if we take this particular example like this one, and if I perform the dequeue operation, what is going to happen, 0 is going to be out of the queue. So once that item, I'm going to pop that item actually, and what is going to happen using that pop method for the list. Okay, but once that item is outside the list, what is going to happen, the length of the list is going to get adjusted. It is not like the block is going to be there. Practically the block won't exist. 50 becomes my, the item which will have the index value 0, right? This is how the things work in a list. So which means that my end is always going to point, or should I say, okay, end, not end, the front. So this I'm going to make, end will be len of q -1. Okay, and front is always going to point to 0, right? Because once we remove the item out of the list, the length of the list is going to get adjusted. So the number which followed by the number which I removed, so the next number is going to be the number which has the index value 0, right? So so the implementation is a bit different, understand it. So let me just check what exactly is the problem that is assigned but never used, and we are going to use this, make this as end as the global variable and front also as a global variable. And okay, it's no issue, there is some warning that is being given out here. Okay, and so that is the enqueue operation, and that's it. Okay, this is the only thing that we require. If there is anything, you can go ahead and improve it. So then dequeue will be the same thing, that is the queue, and okay, only the queue, because I just want to pop the item out of the list. So the same thing, the same checking I'm going to do out here, and if it is empty, then I need to assign front and end as none, and then the else part. Okay, so there is some indentation problem out here, I guess. Let me just fix this. Okay, it looks good to me. Then the else part is I need to pop the item, so I'm gonna say queue, and now I cannot just use the pop operation just like this, because this is going to pop the last item. Okay, so I need to give that index value, that is 0. So if I give that index value 0, it is going to pop the first item from the queue, and this is what I want, right? So that was the item that I'm going to pop, and then I can adjust the end and the front same as it is. Okay, so this is the operations of enqueue and dequeue. Go ahead and implement the entire program. Any room of improvement, any errors, logical errors, please rectify it. I'm just wrapping this up. Okay, so this is the thing, children. Please implement the rest of the code, and I hope the concept is clear to you. Okay, so that's it for today, children. Bye for now.